Right here up front with the chuck, and the chuck is what holds the drill bit or the screw tip into place so you can do what you want to do. Now this drill driver actually has a keyless chuck, so when I want to put the drill bit in, I can put it in reverse, open it up, drop the chuck into place, put it in forward, slowly turn it till the drill bit gets tight, and then lock it down.
And you call this keyless because back in the day you actually had a keyed chuck where you literally had two pieces here. And look, where did this relic come out? The keyless is a lot easier. All right.
Right. Okay, so the next feature on this is right here. There's actually multiple features. So right here on the top of the drill, there's a setting that shows a picture of a drill bit. And this is the setting that you want to be on when you're drilling holes.
Okay.
All right? Now, the other setting right here is for driving screws. And this actually has a setting that works in conjunction with these numbers right here. All right, and that's a clutch. But if you turn one more setting on this drill, you actually have a hammer. This drill actually allows you to drill into masonry. And when you drill with this, it actually hammers the drill in at the same time that it is spinning.
And so depending on which setting you have, this drill is going to operate differently. So if you're in the drill setting, for example, you're going to be able to spin a drill bit very fast to drill into, say, wood.
Right. So I want to have it on high speed. I put my drill in the chuck. I lock it down. Now when I drill, the drill will spin very fast.
Yep.
All right. So now if I take that out and I put a driver tip in, lock it down, and I change my setting to screw. All right, now this setting right here is the torque setting. So let's set it on 16, which is the high torque setting. Put my tip into the screw, and now watch what happens when I drive the screw into the wood.
Right, so that gives you a lot of muscle, but right there at the end, you hear that slip.
That was a clutch.
Right.
And that clutch actually stops the screw from stripping out or the tip from being ruined.
And you know what? That is key, because if you're trying to drive a small wood screw like this, let's say you're hanging a hinge, it is so easy to strip that head right there.
Sure is. So what I want to do is I want to lower this clutch all the way down to number 1, and I drive that screw in and see if my setting is correct.
And there it is.
I didn't overdrive the screw, but it's still not down quite where I want it to be. So now if I just change my clutch setting, let's go up a couple of numbers. Now I'm on 7, and let's see where it drives it. It'll clutch out.
Perfect.
So I've driven the screw just a little bit below the surface, but I haven't overdriven it.
I like the clutch.
Yeah. All right, now
that clutch set, I'll go ahead and install a small fastener in a hinge, and it'll just apply that perfect amount of pressure and kick out, get a nice installation every time.
right here, this is a high and a low setting, 1 and 2. So if I'm drilling a hole and I want to really drill that hole at a high speed, I set it on 2. But if I need power, like if I'm driving a big screw or drilling a big hole, I drop it down to 1, which would give me more power but slower speed.
Right.
And the trigger right here is actually a variable speed, so I can also control that speed by pulling the switch in and out because it's a variable speed switch.
Mm-hmm. Good.
Right here is my forward and reverse.
Right. So today when you buy these, typically they'll come in a kit, and the second tool might be an impact driver, which is a great tool. You guys use it all the time. But it will not do everything that the drill driver does.
This is definitely more versatile. This will definitely drive screws all day long. This is very noisy, but it is powerful.
Impact drills. The idea of impact drills originated from slug wrenches, as all the impact drivers follow the same motion. Imagine a slug wrench fixed on a hex head or nut. Repetitive hammering at the slug head would slowly reach very high torque, which would be near impossible with a hand wrench. The key feature of impacts is they always have a hex head or square head for socket bit attachment, because a drill chuck would cause too much slippage and torque loss during fluctuating torques impacts usually generates. Another feature is that no load or free spin speed is much higher than other drill, because the drill is not geared down to provide high torque. Let's split up the impact generator in an impact drill. In the diagram, if we were to unroll the shaft where the hammer weight climbs, it ends up like a glass shape. With this, you can get the hammer action in both forward and reverse directions. Looking at the top, if we rotate counterclockwise, we go up the left channel, and if we rotate clockwise, we go up the right channel. We can also see this behavior once key discs are cleared. The spring pushes the hammer. The spring also ensures that the hammer never reaches the top and binds the shaft. The key disc base is attached to the bit holder. When there is load, the base key disc is too much for the high-speed, low-torque motor to turn, which causes the hammer to climb up the shaft, compressing the spring. Once the locking keys are cleared, the spring pushes the keyed weight with high speed, generating an impact. This diagram shows counterclockwise impact generation. The process is repeated very fast thanks to the high-speed motor.
An impact gun works by storing energy in a heavy rotating mass and then releasing it all at once in small impacts against the output shaft. This puts a lot more force on the bolt or nut that you're trying to tighten or loosen, and it takes a lot of the strain off your wrist. This is my personal impact gun, so I won't be taking it apart, but I have one of these. They went on sale for $2 at Canadian Tire, and they're supposed to be able to let you turn a standard drill into an impact gun just by putting it in the chuck. Filmed at 600 frames per second, you can see the hammering action in both tools. For the most part, the bit sits still, except when it is periodically hit by the hammer internally as it engages with the output shaft. Here you can see the hammer and output shaft as they fit together, and the spring that pushes the hammer into the output shaft to give it that periodic hammering action. I cut a slot in the case of the impact gun adapter in order to show about a quarter of the mechanism as it rotates. I'm wearing gloves and goggles because I'm not sure how much plastic it really needs to hold together. Filmed at 1200 frames per second, you can see how the hammer lifts up, spins around, and is driven down by the spring and forward by the drill at a much higher speed than if it were just driven by the drill directly. Because the hammer hits the output shaft at a much higher speed than the drill is spinning, more energy goes into turning the screw. But it only does this twice per rotation, so the average energy is exactly the same as what's coming out of the drill.